Alright, hello everyone. This is the next physics video in our homework set, and this is chapter 32, problem number 61. And so we're given the circuit right here. We got a 12-volt battery and some resistors right here, kind of drawn a little funky, and it's asking us to find the current through each resistor and then the potential difference between each resistor. Alright. So to start with the problem, we first have to make this circuit a little simpler. So by doing that, we need to combine. If you notice, these two are parallel to each other. Actually, all three of these are, but we're going to draw it so you can see it a little bit easier, which helped me. So I redrew the circuit this time, and if you notice, I put these two resistors in parallel with each other, just so it's a little visually easier to see. And then I solved for the resistance total of these two, because two resistors in parallel, remember, is 1 over RT equals 1 over R1 plus 1 over R2, and that's of course for resistors in parallel with each other. So we solve for that and we get RT equals 3.69. So again, I redrew the circuit. As you can see, now we have that 3.69. We still got the 3 and the 16, and now even this circuit right here can be simplified more. If you notice, the 3.69 and the 16 are still in parallel. You see they start at the same point and they have a little connector at the same point. So the book just kind of drew it a little funky to try to mess this up, but you just have to realize that these two are parallel with each other. So using the same equation, I did 1 over RT equals 1 over R1 plus 1 over R2. So plugging in those values, 3.69, 16, we get that the RT is 3. So these two are now going to combine with each other. We're going to redraw the circuit again. So here we go. So we got that 12-volt battery, then we got the 3, and now we got the new 3. This is the new R total. So if we got to do one last step. We got to combine these two resistors with each other. Now for this one, since they're in series, RT, that's just going to be RT equals, coming down a little bit, R1 plus R2. You don't do the inverse law anymore. So plugging in both the 3's, we get the R total is now 6 ohms. So we can redraw the circuit one last time, and it's a pretty simple circuit. We get a 12-volt battery. Now we have the 6 ohms up here. So now we can start solving for what we need for this this problem. It's asking for the current and the potential difference through each through each circuit or resistor. So we know the current formula, I, which is current, equals the voltage over resistor. So we have a 12-volt battery and a 6 ohms resistor. So we know that the current flowing through this, there's a current right here, is 2 amps. So we know that the current, the current right there is 2 amps. But see, that's not an answer yet. We need to solve for the individual resistors. So coming on to the next page of my work, we still got that 12-volt battery. And now I broke up the resistors. I'm going backwards now. We're kind of backtracking so that we can resolve for each resistor. So the resistor, we got a 3 amp one, or 3 ohms and the 3 ohms. We're back to that step, and we still have that 2 amp current flowing through both of them because they're in series with each other, and we know that the current will stay the same. So right now we know that for this 3-1 that the current is 2 amps, and now we need to solve for the voltage. So we solve for the voltage. We get V equals IR, and we plug in the numbers. We get I, which is 2 amps, and then R, which is 3 ohms, and we know it's 6 volts. So we can go down to our table, and we know for that 3 ohm resistor, a potential difference of 6 amps, and a current value, or of 6 volts. Sorry, excuse me, and a current value of 2 amps. All right. But now we need to go back to this resistor right here, and we need to break this one back up into its original resistors. So looking at the next drawing, I redrew it back to the way it originally was. See, I drew it a little differently. This is an easier way to see it. See how they're all in parallel. So we know that this 2 amp current comes into this point right here, and it breaks off into 3 different currents. However, the voltage stayed the same from the last problem. So we know that each of these resistors has 6 volts going into each of them. So I can write that 6 volts in there. So now the question is, what are these currents? Because the currents break apart. So we know that I equals V over R, so I just labeled each current and I went through and solved for each of them. So I2 equals 6 volts over 4 amps. That was for this one right here. And then I did which comes out, or 6 volts over 4 ohms, sorry. And that gives you 1.5 amps. And I did I3, which is 6 volts over 48 ohms, which gives you 1.8 amps. And that was for this current right here, coming down the middle resistor. And then finally for the fourth one, we did I4 equals 16 volts over 16 ohms, which gives us 3/8 amps. That was for this one over here. So now we can go into the table and finally plug it all in, or write it all in, so we can see the answer nice and neatly laid out. Here, I'll zoom out a little bit. So as you can see, we got the 3, the 4, the 48, and the 16. There's a potential difference on each of them, and there's the current on each of them. One thing that you notice, here, I'll put this back down for a second. One thing that you notice is that if we were to go back through and add up the I2, the I3, and the I4, we'll get 2 amps, because remember, what current goes in has to equal the current coming out. So we know that the 2 amps equals I2 plus I3 plus I4, which you can see from the table. Alright, thank you.